You all are once again welcome to my channel. Today we will do some practical, we'll get and some practical exposure to the search algos. With the theory, I'll tell you how these algorithms are practically implemented. You can visualize it and you can understand it better. So let us start this lecture. First of all, search algos, many traditional search algorithms are used in AI applications. For complex problems, the traditional algorithms are unable to find the solution. Yes, this is of course because we have several algorithms like we have breadth first search, then we have depth first search, then we have best first search, then we have A star, then AO star, then we have also many algorithms. Actually, the main point is some algorithms are not fitted to find the solution for the complex problems. That's why we have many algorithms. So consequently, many special techniques are developed, such as heuristic function. We will cover it and I'll tell you how this heuristic function can be implemented with this simple algorithms to make to make it easy to solve the complex problem. So move forward. The algorithm that use heuristic functions are called heuristic algorithms. Basically, these are the simple algorithms also in which we implemented heuristic function and it will become an heuristic algorithm. Heuristic algorithms are not really intelligent. They appear to be intelligent because they are achieve better performance. Heuristic algorithms are more efficient because they take advantage of feedback from the data to direct the search path. Basically, before understanding what exactly the heuristic algorithm, you should have to understand what are the basic distances, because because the prior knowledge of this distances, you can't understand the heuristic algorithm. Basically, heuristic algorithm is a kind of search algorithm in which we have different ways of measuring distance. So first of all, you have to understand what are the different kind of distances. So first of all, what you know, that we all know the distance between the 2 points x1 y1 and x2 point y2 is generally what? Its formula is y2 minus y1 whole square plus x2 minus x1 whole square and under the root. This formula everybody knows. This is the formula for calculating the distance between the 2 points. Now actually this is not only the case. This distance is what we call Euclidean distance. Euclidean distance is, I'll show you. Euclidean distance is a square root of current cell minus goal cell. Current cell minus goal cell whole square plus current cell y minus goal cell y whole square and square root. And when to use this heuristic? When we are allowed to move in any direction. So whenever you have to move in any direction, you use Euclidean distance, and the Euclidean distance is nothing but the simple distance that we used. Now there is another distance also, that is what we call Manhattan distance. Now what is Manhattan distance? This is nothing but the absolute values of the difference of the current cell x minus goal cell x. Means there is no square or square root. We have to take the absolute value. So when to use this? When we are allowed to move only in 4 direction. Means like this: upward, downward, left and right and left. So in Manhattan distance, you have to understand we have an liberty to move only in these 4 directions. There is another distance, that is what we call diagonal distance. In diagonal distance, we can move in 8 directions, like in chess games. These are the 4 and 5 6 and these 2 7 8. So there are 8 directions in which we can move, and the distance can be calculated very easily. Here we have to take the maximum of the difference, and of this and this we have to choose that. So based on these 3 kinds of distances, basically we designed heuristic algorithms. Now in heuristic algorithm, basically the way how we measure the distance is a very important matter. So let us move again back to the slides. So I told you what are the different kind of distance. Now based on that distances we can calculate this heuristic function, and heuristic algorithms are not really intelligent. We already covered this, so we'll move forward. There are two kinds of search. This is very important again to understand. One is uninformed search and another one is informed search. Informed, as the name suggested, it is clear from its name. Informed means you have some prior knowledge before solving these kind of problems. But in uninformed search there is no prior knowledge. It is just like a brute force. Brute force means you just apply a hit and trial method to solve the given problem. If it gets solved, then it's your chance. By chance it gets solved, then it is your luck. Otherwise there is no specific way to solve this kind of problem. That's why it is called uninformed search. But in informed search, as the name suggested, it has some prior knowledge. That prior knowledge we are given it to with the help of heuristic function. This is very important. In every informed search there is a heuristic function, but in uninformed search there is no such kind of prior knowledge. I think you understand. We'll move forward. Now see, this is basically a chart through which we can understand what are the different kinds of algorithms available in AI and how they operate. So let us start one by one. Search algorithm basically classify into two groups. One is uninformed, informed, we already studied. In uninformed search there is no heuristic. Mind it, there is a heuristic, we already covered this. And in uninformed search there are basically the mainly three algorithms available. One is what we call DFS, BFS and CFS. In DFS it is based on LIFO, and BFS it is based on FIFO, like a queue. And CFS is a cost first search, in which we search cost wise, means whatsoever, like in disaster algorithm, wheresoever the least cost is available, we move on that track. So in DFS basically we will cover these algorithms one by one, but in DFS we firstly move towards the depth and then traverse back like a tree you studied. In BFS we generally search breadth wise, like this. And in depth limited search we fix some depth till it is just kind of fixing the level of algorithm. Till that level only the algorithm gets searched, otherwise it gets stopped. If we are talking about informed search, they are of it is the one of the best example is best first search, which is nothing but the combination of just DFS and BFS with heuristic function. And there is a hill climbing, generate and test, problem reduction, constant satisfaction, mean and analysis, A star and AO star. See, A star is advanced version of BFS, and problem reduction, the example of problem reduction is AO star search. So we will cover every algorithm with help of a simulator, where you can easily visualize how these algorithm works. So let us start. We'll move quickly on breadth first search. We already covered in the last lecture also. Breadth first search, in which the search is breadth wise. So this is its algorithm. I request you to just from the exam point of view, you have to learn this. Create a variable called list and loop until a goal state is found or list is empty. Remove the first element from the list and call it E. If the list is empty, quit. Otherwise, for every path, each rule mention the state E and do these three things. Apply the rules to generate the new state. If the new state is a goal state, quit. Otherwise, you have to add the new state to the end of the list. So this how till the time the list get empty, you have to follow this algorithm. This is very easy to implement. I'll show you its practical how it used. See, this is a simulating tool in which we'll simulate the breadth first search. See, there is a breadth first search, and there is it is not an heuristic algorithm, so there is no selection of the paths. So this is the starting point, this is the ending point. Now we'll create some the blocks. These are the it's a kind of obstruction in the path. We'll create as many as you want. You can create your own path. So I'll show you how this breadth first search will move. So what you have to do, you just have to create the obstruction first, and you are freely to move these points also. You can move it See, if you want to start it from here and ending till the point here, so you can do that. Now you have to do simply the start search, and see, this is doing the breadth first. They move towards a breadth first. The breadths are searched first, and then it is gradually moved towards the goal state. All the breadths around this start state firstly covered, then it moved towards next, then next, then next, till the time we'll get this our result. Now you see this thing, this is very important. The length of the total length from this start point to the goal point is 24.56, time taken is 4.8 milliseconds, and total operation use is 1204. So see, this is how the breadth first search is worked. It is just like a list, LIFO. You have to empty the list. When the lists get empty, you find the path from the initial state to the goal state. Hope you understand. So we'll move towards the next algorithm. There are some advantages and disadvantages of this breadth first search. Number one is guaranteed to find an optimal solution. Can always find a goal node. If one exists, there should be a goal, otherwise it will move into the loop. And one disadvantage is it required a high storage requirement. This is basically one of the major disadvantages of breadth first search. So we'll move towards the next one. Like in breadth first search, there is one more algorithm, that is what we call depth first search. In depth first search, we firstly move towards the depth, then we'll move back. It is based on the principle of FIFO, or this is a simple algorithm that we have to use. If the starting state is a goal state, quit and return. Otherwise, do the following until the success or failure is signaled. Generate the successor to the starting state. If there is no more successor, then signal is failure. Call depth first search with E as a starting state. If success is returned, signal success, otherwise continue in loop. This is very easy to understand, and these are its advantage. It has a low storage space, easily performed, but it has two major disadvantages. Number one, many find a suboptimal solution. Sometimes the solution that you find, it is a solution but it is not optimal. And second one, sometimes it is incomplete. Without a depth bound, may not find a solution. If there is no bound in the depth, so it may sometimes never end with the solution that exists. So that's why we again formed one more algo, that is what we call bounded depth. And bounded depth, the problem that is in the depth first search, that it sometimes never end. It now solved in bounded depth first search. So these algorithms are very rarely used because these are not the heuristic one. To get the optimum solution, we will go for informed search, that is what we called heuristic search. So heuristic, we already covered what that exactly is. If you want to understand, you just read it out. It will increase the efficiency of the search, and it has some prior knowledge. Definitely it uses some distances that I told you in the beginning of the slides. So we'll these are the heuristic search, definitions of heuristic search, and these are the characteristics of heuristic search. This is very important from the exam point of view. The definition of the characteristics are like, number one, heuristics are knowledge about domain which helps search and reasoning in its domain. Heuristic search incorporates domain knowledge to improve efficiency over blind search. Heuristic is a function that, even applied to a state, returns values as estimated merit of state with respect to goal. And heuristic that underestimates are desirable and called admissible. And heuristic search functions estimate cost and the current state of goal, presuming function is efficient. So these are the characteristics of heuristic search, and this is sometimes asked in the exam. So I'll advise you to just pause the video and note down all the characteristics of the heuristic search. Now we'll move forward. This is a comparison of algorithm of brute force, and it is similar. It is uninformed, and this is informed search. Uninformed can only search, that is the knowledge about ready already and no knowledge about how far a node. This is the brute force or blind search or uninformed search. And in informed search, which is also called heuristic search, estimates the distance that I told you in the beginning of the slides and guides search process towards the goal node from the goal state. That's why we prefer these kind of search. So I demonstrated you how these heuristic search are better than these normal search. Before starting the demonstration, one very important algorithm is left, that is what we call hill climbing algorithm. In hill climbing, there are some points, that is what we call shoulder, global maximum, local maximum, and then flat. So you have to understand this. Shoulder is like a path, which is a flat path. Global maximum is the top of the, it is the goal state that we want to achieve generally, and local maximum is it is not the global maximum, but it is the maximum among the locals is what we call local maximum. Then flat is also, there is a problem that this is a problem that we have to address. So local maximum, it is a state which is better than the neighboring state. However, there exists a state which is much better than this, that is what we call global state. And global maximum, it is the best possible state in the state space diagram. Then plateau or flat local maximum, it is a flat region of the state space where our neighboring states have the same values. This is very important. Ridge, it is a region which is higher than the neighbors but itself has a slope. So these are the basically problem: ridge, plateau, and the local maximum. In the hill climbing algo, we must have to understand what are these problems and how to overcome these problems. So these are the three basic problems: local maxima, plateau, and ridge. We already defined this. Local maxima is a maxima as opposed to the global maximum, and plateau an area of the search space where evaluation function is flat, that is what we call plateau, and ridge where the steep slopes and the search direction is not towards the top but towards the sides, like this. So these are the three main problems in the hill climbings and how to overcome this. So to overcome the local maxima, we have to use the backtracking technique. Maintain a list of visited state. If the possible reaches an undesirable state, it can backtrack to the previous configuration and explore the new path. Similarly, like a plateau, in a plateau there are two on plateau all neighbors have same value, hence it is not possible to select the best direction. To overcome this plateau problem, we have to make up big jumps, randomly select a state far away from the current state. Chances are that we will land at a non-plateau region, but this is the only way how to overcome the problem of plateau. Then ridge, any point on a ridge can look like peak because movement in all possible direction is downwards. So hence the algorithm stops when it reaches this state, and the only way to overcome the ridge problem is use two or more rules before testing it implies moving in the several direction at once. So these are the very important from the exam point of view. They will definitely ask you what are the problems in the hill climbing algorithm and how to address them. So this slide is very important and I'll request you to just make a notes of this, and this is very important from your exam point of view. Now we'll move towards the practical prospects of how these search algorithms are practically implemented. I'll show you one by one. By visualizing the practical, you can understand these algorithms better than this literature. So we'll move towards that. See, we already covered breadth first search. Now we'll move towards best first search. Now in best first search, see, best first search is a combination of depth first search and breadth first search. So it is an heuristic algorithm. So see, there is a Manhattan, Eclodian, and Chebyshev and Octile. These are also called distances, but we are basically concentrated on these two: Manhattan distance and Eclodian distance. Eclodian means you can move in all direction. Manhattan distance means you have to move only in two direction. In Octile, that is another name of diagonal distance. So we will explore these three. Chebyshev is also one of the way to calculate the heuristic, and it is also a way to measure the distance. So we will again search from, first of all, we'll again search from this initial state to the goal state with this Manhattan distance selected, and we'll select the allowed diagonals. So if we restart this, then see how it measures. See, it is very fast and it measures, straight away, not like a diagonal search that we already did. It applies in best first search, it applies somewhere the depth till this point and then breadth. So this is how it works. I hope you understand. Now if we taken the Euclidean distance and restarted, Euclidean means again in all direction you can move. So see the distance is almost same, and the time taken or operation in this is 103, and in Mahantan we'll repeat it once again. It is again 103. So it means the distance doesn't matter. The way we use the heuristic algorithm for this search is almost same. So but you understand how this is different from breadth first search. I'll repeat it once. Breadth first search. In breadth first search, see, you have to cover all the breadth first and then move towards the goal. This is how the breadth first search moves. But in best first search, it is moving straight away towards its goal. That's why it is better, and this is an heuristic search. Similarly, if we are talking about A star is also a kind of best first search, but with there is an additional weight. We also consider the cost function in here. So when we do it with A star algorithm, you see it is much faster, in fact the faster than that best first search. So this is an example how to, A star is different from the best first search. Similarly, there is one more search, that is what we call IDA. Now IDA is what? IDA is iterative deepening A star. This is one very important algorithm which is an advanced version of A star. Here we also use weights and with the time. So when we search with this, you see it gets stuck here because there is no way, but the best possible way by this algorithm is selected as shown here. So this is a iterative deepening algorithm. So I'll advise you to just go through all these algorithms. So if we want to apply Dijkstra's, it is the shortest path first, and it is not an heuristic algorithm. That's why there is no option given here. If we restart from here, then it also work as an DFS and move towards its goal, breadth first search, and move towards its goal like this. So hope you like and you are clearly visualize how these algorithms are different from each other, particularly the unguided search with the uninformed search with the informed search. You have a clear picture in your mind how these algorithm works and how they are different from each other. I advise you I'll share this link at the bottom. You can and advise you to practice yourself by constructing a different blocking paths, and you will see how the time and operations are different in the different algorithms. So you just do the practice. In case you face any problem, you just make the comment in the comment box. I'll try my best to address that. So hope you like this video. Till the time I'll come up with some new innovative videos. Till then, stay tuned. Thank you.